again, what you're looking for is not just the steady pulses. You want the oscillation. And it's easy to get 100% full oscillation all the way across the board, but you do not want that. You want it to reset to 0, and you want it to go into that flop mode. And once again, here's with no resistance at the gate. I'm slowly increasing resistance, and right there, and you got the flop mode. And I can adjust these variables pretty much however I want. I can make the oscillation last any duration that I want per burst. I can make you can do the on time or the off time, and I can make the duty cycle of the oscillations themselves last. So for example, from one burst of oscillation to the next, I can make it as the duration last as long or as little as I want in this flop mode, and this is exactly what you want. So again, not 100% oscillation, not 100% pulsing. You want it right on the verge, and it's a little bit tricky to tweak, but once you get it, you just got to play with it for a little while, and you're going to be able to grok what's going on, okay? And so basically, you want it to where you're getting both. You get the bursts, you get the normal, you get the bursts, you get the normal, you get the bursts, you get the normal. And so, I don't know about you, but anytime I've worked with oscillators using transistors, it's either going to be one or the other. It's going to be oscillating, or it's going to be in regular switching mode, but it's not going to fade in and out of both all by itself. And you can see that temperature dropping, but I changed the settings and everything just to show you this demo here. And so anyway, I hope that that's helpful, and all you got to do is just continue to play with it, and you get it. It's not that hard. Just get some 10-turn pots. Otherwise it's kind of nerve-wracking using any kind of big one-turn pot, because you do want precision for this. So 10-turn pots on the off time, on time, and the gate, and I did post the schematics at Energetic Forum. So anyway, and thanks to Tektronix for letting us borrow this for the testing. It's the TDS 3054C, and you can go to tektronix.com to check it out. Thank you. Okay, this is a quick clip here just to show that you're able to vary the duty cycle of the oscillations, and that means perfect control, stabilized oscillation at any duty cycle wanted. So for example, right here you can see that the oscillation burst is maybe 40% of the time or so. So that would be a 40% oscillation duty cycle. Okay, and you can see up here the battery recharge corresponds to the oscillations on the battery in addition to the initial spike. Okay, so anyway, this is 0, and I just have this set across the load right now. The blue is across the battery and the bottom is across the shunt. Okay, so what I'm going to do is I'm decreasing the resistance, or I'm increasing resistance on the gate from 0 on up. Okay, and then I'm going to hit the point for this particular coil, which I'm using the bigger coil. Okay, and you can see that that's a pretty big, pretty long duty cycle out of the hole, which is a pretty long burst. And so you're just going to have to do the experiment yourself, and then experiment with the oscillations at a long burst, and then normal, short normal, long oscillation, short normal. Or it can be varied. Well, I'll just keep increasing the resistance, and it breaks it up into smaller pieces, and you can see all those little bursts of oscillations. Okay, and then I'm just going to keep increasing it, and you can see that they break down even further. And you can see right here, I'm getting more and more of them. Okay, so I just effectively reduced the oscillation to about 25%, 20% or something. And so we can basically zoom in here and we can see it's actually pretty incredible. So anyway, normal pulse, oscillations, normal pulse, oscillations, and you can see that's the battery voltage dipping, coming down and then getting charged. And every time the oscillation happens, it's producing heat in the resistor, but every time the oscillations collapse too, it's also recharging the battery all the way across. So it's basically putting into the battery what it's taking out minus any loss through any of the components, any diodes in the MOSFET and so forth, but essentially it's recharging itself as it's running at the same time. Okay, and I'll just keep increasing resistance a little bit. You can kind of see that now it's gone. Okay, it's still there. Gone. Okay, now I got too much resistance. Now I'll go backwards. There's a little bit. More. Oscillation is more dominant. Now I'm back to too little resistance. Now this is zero resistance. Come back up. 100% full control, anything that I want it to do. So there it is, the burst of oscillation, normal, burst of oscillation, normal. That's the pattern that you want. You just have to experiment. How much of it do you want oscillation? How much do you want normal pulsing? And doing the drawdown tests is basically going to be the only way that you're going to know